Welcome back. We are going to continue with the buying pizza exercise and how to discard the dry edge. And how is that going to alter our decision between buying one or two pizzas? The easiest way to adapt for the edge is to modify our already coded function and add the parameter edge. So everything looks the same, area diff, but now our functional values are going to depend not only on the d diameter but also on the thickness of the edge. And our task was to implement this into our expression for our variable diff. So we can copy actually the expression what we coded above. And now we need to incorporate the edge parameter into our expression. So on the cross section of the pizza we have actually two edges. So from the diameter we need to subtract the value of 2 times edge. So here, since we are dividing by 2, we need parentheses. So d minus 2 times edge. And close the parentheses, and all that divided by 2. And this of course applies also for the bigger pizza. Just now we already have the parentheses, we have d plus 10. And again, minus 2 times edge. So now it looks fine because, as I said, the difference in the areas depends on the d and depends on the edge. We can run the cell. One more thing deserving my explanation is this expression edge equals 0 in the definition of our area diff function. This is a useful one which tells Python that if the user does not specify any value for the edge argument, it should assume that it's equal to 0. So the function will work and it will be used as we had it in the first part of the exercise. Therefore, the author of the function can specify some kind of default behavior for his functions. Now we are ready to repeat the fsolve part. Fsolve, area diff, that's the same. x0 is the same, let's say 15. And additional arguments to fsolve are passed through the argument called arcs. And that's our thickness of the edge, which we want to be 1 centimeter. We run the cell and we see that the return is altered from 24.14 now is 26.14. Now we are going to plot both functions again, so the original one and the one when we discarded the edge. Again using plt plot, original one was d and functional values were f, and we are going to add label in order not to confuse them together. So this one is when the edge was in, and the second improved solution was d. And now we did not define the functional values, but we can calculate them right away in the plot command. So I can write what I had before, area diff, and we had d, and now we specify the edge thickness equals to 1. And this label will be edge out. Run the cell. Here are our two parabolas. The blue one represents the original one with the intercept with the x-axis around 24.14. And the orange one, once we discard the edge, is getting shifted to the right. This is sort of the end of the exercise, some food for thought, so the questions which you can further implement or just think about. Is it correct that the curves for diameter less than 10 are increasing? How do you explain that? And can you adjust the notebook for the case that you go for pizza with 2 friends, so you are comparing 3 versus 1? And how would you proceed if the price of 2 smaller pizzas would not be exactly the same as 1 bigger pizza? Congrats for finishing, and see you at some other exercise or other notebooks. Cheers!